Assalamu alaikum students. Our course is Electronic Devices and Circuits, and my name is Dr. Jahangir Arshad. I am serving as Assistant Professor in Electrical and Computer Engineering Department, ComSets University Islamabad Lahore campus. And today our first lecture will be about introduction of electronic devices and circuits. Here you can see my details and my educational background, my office information, and email address for contact. Let's start from the basics of electric circuit analysis, which you have studied already in your first semester. And first thing you have gone through is charge and electrons. If we define this thing, a physical property of matter that causes it to experience a force when placed in an electromagnetic field. That has two types. It could be positive, which is due to protons, and it could be negative, which is due to electrons. Current, it could be also of two types. First one is DC current or direct current. Second one is AC current or alternating current. An electric current is the rate of flow of electric charge passed in a point or region from one point to another point. If you move charge, it causes current. And as I already told you that it has two types. It could be DC current or AC current. DC current is the current which doesn't change with respect to time, and alternating current is the current which changes with respect to time. Next property or next parameter, which is called voltage or potential difference. Um, in simple words, we can say the flow of charge is caused due to this voltage or potential difference. It can be defined as voltage electric potential difference. Uh, Electric pressure or electric tension is the difference in electric potential between 2 points. It could be voltage is equal to energy per unit charge. And then the next thing is power or energy, rate of doing work or transforming energy or transforming heat, such as the amount of energy transferred or converted per unit time is called power. Then next thing is electric circuit elements. Again, there are two types of these elements. First one is active, and second one is passive electric circuit elements. All electrical components can be divided into two categories, active or passive. If any component delivers the power to the circuit, it belongs to active component category, and a passive element is an electrical component that does not generate power but instead dissipate, stores, or and release it. Then if we define electric circuits, path in which electrons from a voltage or current source flows, the point where those electrons enter is called electrical circuit, is called source of electrons. The point where these electrons leave an electrical circuit is called return or earth ground. So these are very basic parameters which creates or builds some background, and you have already gone through all these things in very detail in the course of electric circuit analysis. Now let's start the introduction to basic electronics. What is electronics? Electronics is the science of how to control electric energy, energy which the electrons have a fundamental role. It also deals with electrical circuits that involve active electrical components such as vacuum tubes, transistors, diodes, and integrated circuits, and associated passive electrical components and interconnection technologies. Uh, we will work with several basic electrical components when building electronic circuits, including resistors, capacitors, diodes, transistors, and integrated circuits. Here is a brief overview of the function of each of these basic electronic components. Now, let's discuss few types of electronics. First one is digital electronics. If we deal with digital signals, we will study digital electronics. If we talk about the second type, it is analog electronics. Analog circuits manipulate analog signals whose performance is more subject to manufacturing tolerance and signal attenuation and noise. So analog signals are dealt in this type of electronics. Then third one is optoelectronics. If we study electronics and light together, this combination or this branch of technology is called optoelectronics. Then micro and nano electronics, it includes the design and fabrication of end of the roadmap electronic devices such as 2D or two-dimensional materials for flexible electronic gigahertz, analog to digital converters for advanced wireless communication systems, and terahertz transistors. Then the fifth one is integrated circuits. An integrated circuit or monolithic integrated circuit is a set of electronic circuits on one small flat piece or also called chip of semiconductor material. Then the last thing, uh, semiconductor devices. A semiconductor device is an electronic component that relies on the electronic properties of a semiconductor material, such as you can say silicon, germanium, gallium arsenide, as well as organic semiconductors for its function. Semiconductor devices have replaced vacuum tubes in most applications. Then, if we talk about advantages of electronic circuits, these circuits are used in computers. These are also used in pen drives, all the applications of mobile technology and television technology. Then, enhanced technologies in cameras, Internet of Things, and automation. And recently, it is very popular in artificial intelligence and banking sector where you are using different ATM machines. So these all applications take advantages of electronic devices. Then uh, key application areas of electronics are communication, entertainment, defense purposes, then industrial applications, and very famous these days biomedical and next generation healthcare systems. All these electronics are used in these specific areas, and the list of applications is not limited to the provided one, but there are many other areas of usage of electronic devices. Further, if we talk about passive electronic components, uh, transformers, integrated circuits, multimeter, ohmmeter, capacitor, resistor, display devices, including LCDs, CRTs, these are passive electronic components. Details of these components are also provided here. Transformer is an electronic device that transfers electrical energy two or more circuits through electromagnetic induction. Commonly, transformers are used to increase or decrease the voltage of alternating current in electrical power. Transformers can thus be designed to efficiently charge AC voltage from one voltage level to another within the power networks. Transformers also can be used in televisions, microwave ovens, computer, and electric stations. Then, integrated circuits. These are chips, uh, also called small electronic devices made up of semiconductor materials. The first IC was developed in 1950 by Jack of Texas Instruments and Robert Noyce of Fairchild Semiconductor. ICs are used for a variety of devices including microprocessors, audio devices, video equipment, automobiles, and other home appliances. Uh, Operational amplifiers, timers, comparators, switches, all are available in the form of ICs. Then a multimeter, also known as a voltmeter, is an electronic measuring instrument that combines several measurement functions in one unit. You can measure voltage, current through it. Then capacitor, the next passive element is a capacitor. It is a two-terminal electrical component used to store electrical energy temporarily in an electric field. Capacitors come in several different varieties, the two most common being ceramic disc and electrolytic. The amount of capacitance of a given capacitor is usually measured in microfarads, abbreviated as microfarad. Here you can see different types of capacitors as well. Then resistors, very important component in electric category. Resistor is a passive two electrical component that implements electrical resistance as a circuit element. Resistance act to reduce current flow and at the same time act lower voltage levels within the circuit. If you put resistor next to a penny, you get an idea of how small they are. And we have already studied how to measure different values by using these bands which are displayed on the body of the capacitor, a body of resistor. It could be any of the colors provided in this table, and then first band shows the value of resistance, then second is also the same, then third will provide you that how much number of zeros placed in calculation of value of the resistor. Then the level of tolerance is also provided here for different colors. For brown it is 1%, for orange it is different, for green it is plus minus 0.5%, and if it is gold or silver, for gold it is 5%, for silver it is 10%. So this is the way how to calculate the resistance while you are provided with a resistor, and you have studied all this in your electric circuit analysis course. Then the next thing is passive active devices, which includes sources of energy, batteries, generators, tube devices including vacuum tubes, gas type devices. Semiconductor devices are of two types. It could be diodes, transistors, or other types. If we talk about diodes, it is a PN junction, or it could be Zener diode. If we talk about transistors, it could be BJTs, FETs. We will go through all these devices in this course. And now let's come to the classification of semiconductors. There are two types: intrinsic semiconductors and extrinsic semiconductors. If a semiconductor is doped, it is called extrinsic. If it is not doped, it is called intrinsic. And extrinsic is further divided into two types: N-type semiconductors and P-type semiconductors. P-type semiconductors, it is you can see a diode is formed of two types of materials. First one is P type, then the N type, and this is called anode and this is called cathode. Excess holes diffuse to the N type region from here, and excess electrons diffuse to the P type material from this type of material. So this flow of electrons cause flow of current, and we will study all these things in details, how this diffusion is formed and how flow of electrons can be controlled, and then a depletion region is formed closer to this junction, which is a connection part of P-type and N-type materials. If we talk about diode, we must know four parameters. First one is depletion region, then second one is potential barrier, then forward bias, reverse bias, and let's discuss these things one by one. Dopant distribution in PN junction diode, excess holes diffuse to the N-type region. You can see that holes move towards N-type region, and these excess electrons diffuse towards P-type material, and this is the depletion region in which the positive charge gathered closer to this junction and negative charge also gathered to this closer to this junction, and this region is called depletion region. Then potential barrier, up to some extent electrons diffuse across the junction and the point reach where negative charge repels any further diffusion. It is the point when diffusion of electrons is no more, and depletion region now acts as a barrier. In this situation, external energy to be applied to get the electrons across the barrier of the electric field. Potential difference required to move electrons through the electric field is called potential difference or potential barrier. Barrier potential depends upon temperature, amount of doping, type of semiconductor material, such as if you are having silicon, its potential barrier could be 0.7 volts. If you are using germanium, it will be 0.3, and if you are using gallium arsenide, the third one, you can say that that will be 1.3. And now the next thing we must know before going towards the regular or discussion of the book chapters, we must know about forward biasing. If the battery is connected in a way that positive terminal is connected to P-type material and negative terminal is connected to the N-type material, the depletion region will be shrinked, and the negative charges will gather with this junction and positive from here will gather with this junction, and free electrons will move in this direction and holes will move towards the other direction, and the depletion region will be narrowed region. So in forward bias we can say that positive terminal is connected to P-type, negative terminal is connected to the N-type, and the flow of electrons, free electrons will be towards this direction and holes will be towards this direction. Contrarily, if we look at this diagram, in this that negative is connected to P-type material and positive is connected to N-type material, here free electrons will move away from the junction and positive charge will gather closer to this junction, and the same way holes will move away from here and negative charge gathered closer to the junction. So it will widen this depletion region. So we can say in reverse bias situation the depletion region is quite wide, while in forward bias direction the depletion region is narrowed. Further, if we talk about different types of LEDs, light emitting diodes are also a special type of diode that emits light when current passes through it. It is very in the market these days. You can see LEDs everywhere. Further, the last thing is transistors. Transistor is a semiconductor device used to amplify and switch electrical signals and electrical power. It is composed of semiconductor material with at least three terminals of connection to an external circuit. Here you can see different types of transistors. That's it for today's lecture. We will start our regular studies from chapter 1 of book, and we will going through the Floyd 11th edition, and see you next time. Goodbye. Allah Hafiz.